17 years ago, a warm wind was blowing across the Pacific. As it blew, it pushed sun-warmed waters westward, piling them high to the northeast of Australia. When the winds eased, the warm waters washed back across the vast ocean, releasing masses of heat to the atmosphere in what became the mother of all El Niño events.
The Florida storms are being blamed on El Niño.
Wild storms and heavy rain in South America.
A man-made permanent drought.
It was 1998, and the climate seemed set on a frightening trajectory.
What the world is experiencing could be part of a climate shift.
In a few years or a decade or so, we'll go into a permanent El Niño.
But the years that followed didn't live up to predictions, leading to a crisis of confidence.
They have been deliberately exaggerating the evidence, overstating the case, frightening people, frightening even children.
The globally average surface temperature hasn't increased in any significant way since 1998.
In fact, it can be argued since 2003 it has cooled off somewhat.
It became the most important question to answer in climate science today. What happened to global warming? It's a cold and blustery day in Boulder, Colorado. It seems a fitting start to a story on what's become known as the global warming pause. It's a well-established fact that people are less likely to believe the world is warming when there's cold weather about. But it was also here at the National Centre for Atmospheric Research that a distinguished senior scientist found himself at the centre of a climate conspiracy storm.
This related to what was subsequently called ClimateGate, in which a whole bunch of emails were stolen.
Among the many hacked emails in the 2009 ClimateGate scandal was one from Dr. Kevin Trenberth to a colleague. Sceptics seized on one particular sentence as written proof that climate scientists were involved in a large-scale cover-up.
It was picked up as me saying that there was no global warming, somehow or the other, and completely misinterpreted, and it just propagated all over the place. It was amazing to see.
Yet, the world didn't seem to be warming. At least not much. While the period from 1975 to 1998 had seen a rapid rise of global average air surface temperatures, in the years since, the rate of rise has slowed dramatically, leading a vocal minority to question predictions of catastrophe.
So we're getting this growing divergence between the observations and the climate model simulations.
You have at least to consider the possibility that the models are not reliable for one reason or another.
On one point, the sceptics were right. None of the models used in future climate projections predicted the hiatus. And while the slowdown for the first few years was written off as natural variability, lately it's become something to explain. From the data he's been analysing, Dr. Trenberth sees a planet heating up just as fast as ever.
We can look at the energy budget of the Earth by looking at information from satellites that are flying above the atmosphere, which actually track the incoming solar radiation from the sun, how much is reflected, and how much the Earth is radiating back to space. It's not absolutely accurate, but it does track the year-to-year variations very well.
His calculations show our budget is continually in surplus. More energy coming in than leaving the atmosphere.
Given that there's an energy imbalance, where does that energy go? How much has gone into the oceans? How much has gone into melting Arctic sea ice, warming the atmosphere, warming up the land, changing evaporation and therefore changing clouds, which can also change the brightness of the planet. And when we first did this, there was some quite substantial discrepancies that in some years we can't account for where the energy has gone.
And that was the cause of the frustration expressed in Kevin's email. monitoring systems simply aren't sophisticated enough to track all of the heat exchanges on the planet. The main focus in global warming has been air temperatures because it's the easiest to measure and it's the temperature we feel. But it's a tiny fraction of the planet's total heat content, and it's also highly variable. As greenhouse gas emissions have risen over the last century, the long-term trend in air temperatures is obvious. But zoom in on the chart and you'll see fluctuations. These swings are put down to natural variability. The current hiatus is no different. But this time, climate scientists have been under pressure to pin down the exact cause. There have been several.
So the sun went into a relatively quiet phase. In addition, there have been a number of small volcanoes that put debris into the stratosphere that blocked the sun. And what about the air pollution? China has been developing enormously. What has that done?
In total, aerosols and solar activity are thought to account for about 20% of the pause. But the biggest contender for where the rest of the heat is going is the one that's hardest to measure. The oceans absorb a whopping 93% of the world's excess heat.
I've been working with the European Centre for Medium Range Weather Forecasts, and they have developed an ocean monitoring system that synthesizes all of the information, sea level measurements, the measurements from the floats, sensors that are measuring sea surface temperature and so on. And what we found is that after about 1999, a lot more heat is going deeper into the ocean. And this is unprecedented. Is this just a consequence of the change in the observing system, or is it real? And I think we have good reason to believe that at least some of this is real.
Multiple lines of evidence converge here in the Pacific, the largest and deepest ocean in the world.
If you rotate the globe around, that's all you see for part of this hemisphere is just a big fat piece of ocean. The Pacific Ocean is huge influence on climate.
Professor Matthew England has been key to nailing down how the Pacific has been dragging down world average temperatures.
We had to look for something about the climate system post-2000 that was dramatically different to the climate system in the 80s and 90s. And one of the most dramatic things you see in the system is this flip in the Pacific Ocean. If ever you travel to the tropics in the Pacific Ocean, there's a prevailing wind from the east towards the west. And these easterly winds push a lot of the surface water across the West Pacific Ocean. If they remain for long enough, this water starts to get subducted into the ocean interior. During the 80s and 90s, the winds were quite weak. Not a lot of heat was getting subducted into the Pacific Ocean during that time, and a lot of heat was remaining in the atmosphere.
Then came the massive El Niño event 17 years ago.
In 1997-98, there was a tremendous amount of heat that came out of the ocean, and we can measure it. And so the ocean actually cooled quite substantially. And so we think that this may have then kicked the whole behavior of the Pacific Ocean into a different mode.
The ocean once more began to build up heat. The change in the way the ocean either releases or draws in heat is part of a regular long-term cycle called the Pacific Decadal Oscillation. Each phase lasts around 15 to 30 years. When Dr. Jerry Meal from Boulder studied climate models with hiatuses, he discovered they linked closely with the negative phase of this pattern.
And sure enough, the extra heat was going into the deeper ocean. So that was kind of the first tie we had, a tangible link to where the heat was going during these hiatus periods. And this connected then to stronger trade winds.
It was Matthew England who found these winds were unprecedented in strength this century.
The winds are that much stronger than we'd ever seen before in the observations.
The winds are in fact being turbocharged by abnormally warm waters in the Atlantic. As air races from high pressure to low, the winds push the warm surface waters west.
So over the last 20 or so years, the sea level over the West Pacific has risen quite dramatically above the global average sea level rise, whilst in the East Pacific it's declined.
And in this case, it's been piled up to such an extent that there's been a 20 centimeter rise in sea level compared with the Eastern Pacific. And that, to me, seems like a very large number.
It sort of reaches a breaking point, perhaps, where that heat then sloshes back to the East Pacific.
And that then adds to the warming from the increasing greenhouse gases, and you get real sudden increases of temperatures globally. The last time that happened was in the mid-1970s. Global temperatures warmed almost 0.5 degrees centigrade, which is almost half of the warming we got in the whole 20th century.
What that means is we're currently in the phase before the next global temperature jump.
There'll be warming out of this hiatus at some point in time, whether it's this year or in 5 years' time. There's going to be warming, and unfortunately what we're seeing in the models is that the warming out of the hiatus is going to be rapid regardless of when that hiatus ends.
But a small minority of scientists disagree.
That's where I break with my colleagues. I just think there's a lot more uncertainty. We're now in the cool phase of the Pacific Decadal Oscillation, and I think that is the major thing that's causing the pause. And my understanding of the Pacific Decadal Oscillation is that we could stay in the cool phase for another 2 decades. So where does that leave us in terms of thinking that this sensitivity that we've deduced, largely based on this warming in the last quarter of the 20th century, during that period we were in the warm phase of the Pacific Decadal Oscillation.
And this is a thought which is, for about 30 years, people have tried to ignore because it takes away from the thought that most of the rise in temperature is due to increasing carbon dioxide in the atmosphere.
Look, I agree that the warming in the 80s and 90s certainly would have had a component of Pacific natural variability to it, but it was beyond just that. So if you think about the natural system without greenhouse gases, it would see cooling of the atmosphere globally, then warming in the positive phase, and we'd be flatlining over 100 years. We don't see that. We're seeing hiatus decades.
And there is one other possibility, that there is no missing heat. Changes in ocean circulation have changed the pattern of the clouds, which is reflecting more solar radiation, and so the Earth isn't heating as much. So unfortunately, the observations aren't quite good enough to distinguish between those two ideas.
There's no evidence that clouds can account for this hiatus. Many things have occurred over the last 15 years that should have given us one of the coolest decades over the last 100 years. It's actually the warmest on record.
We've seen that in Australia, we've seen that in the United States. All kinds of thousands of temperature records were broken.
A lot of the continental regions have continued to warm up, and we've seen an increase in, for example, heat extremes over a lot of continental areas, all the while that the global average temperatures haven't been doing much.
Arctic sea ice has declined dramatically, way beyond the projections. Sea level is rising faster than we projected even just 5 or 10 years ago.
All things considered, there's been no global warming pause.
The whole of the climate system is really warming, it's just that the warming can be manifested in different ways.
For some people it's very easy for them to get this, but there are other people who are just absolutely obsessed with derailing the basic physics of climate change, and for them this poses a great little story that global warming's paused. I wish they were right, but unfortunately they're wrong.